quite some time. Thank you, sir. Enjoy.
I'll get that back up in a second. But it does sound like we do indeed have audio working. I got a few screws loose up here on the video cable, that is. Was that? Oh, that's right. You love me, right, Dave? I love you. All right. Well, one quick thing I got to show before I continue my talk, and then I will get this thing underway.
So we just arrived at Shmoocon today. Today's Thursday, and hopefully, Chris, you're in the audience watching this, so it should be Sunday by the time you're seeing this, but we're going to do some awesome stuff to the shirt that you're wearing right now in the audience, hopefully. Alright, it's been about 2.5 hours, and I've been walking around Shmoocon with the shirt of my boxers. You see here, this is the XXL. We're giving to Chris with the Derbycon. It's really sweaty in here. I was actually walking quite a bit of distance, so we'll see how it goes. So in order to get to Shmoocon, we actually had to drive about 6.5 hours in the car. And as you can imagine, when you're just sitting there doing nothing, it's get a little, less cleansy down there. So I figured I'd just groom as well. So I'll be back in a couple minutes. Alright, I'm all done now. You don't want to know where this hair came from. Should be mixing there pretty good.
I love you, man.
I got a malicious USB for you.
All right. With no further ado, I'll get cooking on the presentation. I'm not sure if I might run over, so I'm going to kind of cook through the first part of it somewhat. But if you want more details on everything I'm showing, I have like a 40-page paper that's out on my website, and I believe it's going to be out on the Shmoocon website eventually. I sent the PDF to Heidi. But let's get started. Special thanks, of course, to Tenacity Solutions for sponsoring me going to various places and paying for a lot of my research. PJRC, who makes one of the microcontrollers I do a lot of work with. And, of course, Shmoocon for having me here. Thank you, guys. All right, about me. I'm on geek.com, have an interest in InfoSec education. I have this pet theory that it takes a noob to teach a noob. Someone who's been doing something for a very long time automatically takes for granted, what other people are going to know. First witnessed this with the air mouse phenomenon when I was teaching a class. The person would grab the mouse and they would hold it like above the table. It never thought it occurred to me to teach someone how to use a mouse. So I feel it takes a noob to teach a noob, and so that's me, hopefully. Don't know everything, I'm just a geek with time on my hands. I kind of take that as a paraphrase from Bruce Potter, who says, don't trust anybody, don't take anything don't automatically assume everything you hear is right. Question it, think about it, even things that the speaker is saying. And I'm a regular on the ISD podcast, and I do research for the Tenacity Institute. All right, Maltronics, malicious hardware. Let's do a little bit of a definition. Hardware instead of software, essentially you're making an electronic device. Now, there's some software involved, since we're talking about creating your own firmware and whatnot to load on the device. There's a few possible examples that are non-USB for malicious hardware. I'm sure people can think of more. PS2 keyloggers, for instance, backdoored routers. I've heard a lot of talk about those. I haven't personally seen a real credible source, but then again, some people in the intelligence community may very well have, and I just haven't found out about it. Just triggering self-destruct hardware, receive a ping of death and have the hardware actually stop working. That'd be really useful if you're shipping stuff to another country that you might go to war with later on, and you're like, I want to take down their infrastructure. Weaken crypto ships that leak something via side channel attacks. There's all sorts of research, most of it very academic, going into malicious hardware. A little background on USB. Some will be talking about this in greater detail, and I figured there's a few terms I should define. Hardware has identifying strings. This helps the OS know what drivers to load and what to do with the piece of hardware when it's plugged in. two strings that are pretty much on every USB hardware device ever is vendor ID and product ID. And you can get a huge list of what vendor ID and what product IDs are out there. But there's an official website, but I personally find this particular linux-usb.org site to have a lot better list, a lot more usable. Keep in mind, though, that sometimes people clone other people's vendor and product IDs. I got a little device in my bag that says it's from Apple, and it's definitely not from Apple. And also, you can spoof those. And sometimes serial numbers. All right, malicious USB devices. So why am I concentrating on malicious USB devices instead of one of the other types of electronics out there? Well, first of all, there are real examples as opposed to scaremongering. A lot of stuff seems very theoretical, not very immediately practical, not something you can reach out and build yourself right now. Ease of installation. Most USB devices, you plug it in, it automatically installs whether or not you're an administrator in most OSs, depending on what the hardware is. If it's a keyboard or it's a storage, generally speaking, it just comes up. If you're installing like a PCI card that's malicious, that takes a little bit more effort. And even though there are all ones out there, there's actually hardware keyloggers that work on the PCI bus. Lack of admin rights. You don't really need them in a lot of cases, especially for the stuff I'll be showing here today. And it's easy to hide or socially engineer someone else into installing them because it's easy to put it inside of something else, which I'll be showing as well. All right, USB mass storage containing malware. I got basically 4 categories I've been putting all these different malicious USB devices into. The first one being USB mass storage containing malware. This is essentially, how many times is it going to take for that to actually enumerate? Anyway, this is basically hard drives or any kind of storage. That's a demo that definitely fired off way before it was supposed to. But any kind of storage, hard drive, whatnot, it doesn't matter. I'll be going to that. You have your U3 Evil 1 payloads. Is the Hack5 crew in the audience? Well, talk to them about a lot of those details. Hardware keyloggers and programmable HID USB keyboard dongle devices, or usually I just call them by their acronym. All right, we're going to cover the first category, mass storage containing malware. Essentially, the USB spec, there's this mass storage device class that most OSs support, and essentially you plug in it, and instead of having to have custom drivers to access that storage, there's one already built into the OS. Plug it in, you're good to go. And a lot of different products use this. You have your flash drives, of course, card readers, digital cameras, picture frames, and whatnot. MP3 players, of course. Well, sometimes these things can be shipped from the manufacturer with stuff already on them. It's also possible that someone could intentionally load malware on one. But there's also the trigger vectors for these. Because you have your auto-run payloads, there's a gentleman giving a presentation, I think it was just before mine, on when you browse a folder, various exploits that can happen that would automatically run and cause something to happen besides auto-run. But auto-run is one of the classic ones, classic triggers. It can be intentionally ran by the user. For instance, if I shipped you a digital picture frame and it had install.me.exe on it, most of you would probably run it assuming it's the installer. Even the security folks would probably assume that. That might be another example of a trigger vector for that. Could exploit a bug. Like I said, the gentleman that was speaking in another room before me was talking about vulnerabilities similar to this. I think he was maybe covering it in Linux instead. But for instance, the WMF vulnerability and as well as the link file vulnerability that's more recent, essentially you'd bring up Windows Explorer, see the directory, and you'd be hit. It would automatically fire off the exploit, which you could run arbitrary code with. So that'd be another trigger you could pull off with USB hardware storage. Now, there's several real-world examples of people pulling this off. For instance, there was the Moposa botnet client was found on some Vodafones that were shipped from the manufacturer. There was malware shipped on Apple iPods, as well as digital photo frames, which had similar problems. And there's all sorts of stories out there about this. And a lot of times, this comes because of lack of quality control at the manufacturer. All right, detection and mitigation. First of all, user awareness. And I know people hype on the users, and some people say, well, defend the users and we're not teaching them right. But I have my doubts about how much user awareness can really help. Disable auto-run, of course, which hopefully most people are already doing. Keeping patches up to date, for instance, the WF file vulnerability or link file vulnerability, if you're patching up to date, they can't use that. And run malware and antivirus systems. Granted, they're hit or miss. If someone's hitting you with custom malware, you're kind of out of luck, but it's another layer. And lock down what hardware can be installed, which I'll be covering here shortly. The second category is, of course, U-free thumb drives with either auto-run payloads. Pretty much this is like the first category, except for it's all about intent. The first category, I'm mostly throwing in things that ship from the manufacturer mistakenly with malware already on it. Essentially, these U-free thumb drives, you plug them in, there's a partition that looks like a CD, and because it looks like a CD to the OS, some OSs will automatically look on it for the auto-run INF and fire up a process. And attackers, of course, have used this functionality for more than what was originally intended. What was originally intended for was you plug it in, it brings up a little application menu, you can carry applications around your U-free thumb drive. And people like the Hack5 crew have done all sorts of extra stuff with this. For instance, some of the payloads out there are for hash dumping. You know, plug it in, dump the hashes, take it with you. A lot faster than sitting down at the keyboard to enter your commands. Take it back home with you, crack the passwords. You know, install a remote access Trojan would be another example. But they're not always even necessarily used for malicious problems. Let's see. Triggers, of course, auto-run as before. But there's other ways to get it to run. Even if the auto-run is disabled, the person can plug it in and just, you know, double-click it. A few real-world examples. The Hack5 Switchblade. A little bit earlier, I alluded that there are U-free payloads that are not necessarily malicious. For instance, Russell Botterini, he developed the instant response payload. Essentially what the idea was, he couldn't always be at all the places he had to support, so he'd give them a thumb drive with the auto-run on it, tell them if there was a machine that was compromised to plug it in, it would collect a bunch of data, then they could shut down the machine. That goes down to the whole debate about when should you leave a machine up and running and do live forensics, and when you should shut it down to keep it from attacking anybody else's system. So this was his compromise between those two worlds, and it's a pretty neat payload. Plug it in, dumps information about what's in memory, what network connections are happening at that point, what processes are running, and whatnot. Also, another great example is, I'm just going to call him Steve, because I have no idea how to pronounce that last name, from Secure Network Technologies. They were doing a pen test at this credit union, I believe it was, where essentially they left a bunch of thumb drives with a custom written payload all around the parking lot, and they got like a huge return on investment of that, because most of the people who picked one up plugged it into the network, and then they owned the network. And since it was a custom piece of malware, AV didn't detect it. All right, detection and mitigation for these. Once again, user awareness. If people knew not to plug in everything that they pick up, or every piece of free hardware they get, that would go a long way. Disabling auto-run helps. Keeping patches up to date, once again, helps. And running anti-malware and antivirus, while not anywhere near perfect, is an extra layer that can help you. And of course, locking down the hardware, which I'll be showing shortly. Now that those two categories are out of the way, I'm going to say why I'm not going to really focus on them too much. Essentially, what it comes down to is software that's being delivered on hardware storage. Conceptually, this really isn't all that different than the floppy disks of old. So there's already anti-malware vendors out there putting out tools for detecting these sorts of vulnerability, these sorts of threats. So, and the auto-run issues have been largely covered by a lot of places online and a lot of other people, so I'm not going to go into those in great detail. The next two categories, however, are somewhat different. They don't necessarily rely on software that runs directly on the computer to do the job. All right, the first category I'm going to throw up is hardware keyloggers. Now, essentially, a hardware keylogger is conceptually very easy to understand. Essentially, you have a dongle, male USB on one side, female on the other. You plug it in line with your keyboard. It sits there and logs all the keystrokes. Nice and easy. A snooper can then come along later on and grab the device, take it back home, and dump the passwords that you've typed, documents you've typed, URLs you've typed, where you've been visiting and whatnot. Now, the trigger vectors for this, they don't really have trigger vectors like some of the other categories I've been talking about because they're constantly logging. However, there are ways to trigger dumping the payload. And for instance, the key carbon, you type that particular string I have up there, phx log, and it turns into a virtual HID device itself. And well, virtual is not the right term, but just a HID device itself and starts typing in the contents of the logs. The key log's a little different. You hold down KB and S. These are defaults, by the way. You can change them. And it becomes a thumb drive, which you can copy off the log of captured keystrokes in a text file format, which is nifty. All right, a few real-world examples. If anybody has some real-world examples of where these things are being used, let me know. I had somebody at Louisville InfoSec tell me that they had one. I told them to email me, and they never did. I know how someone has to be using this out there because people seem to sell a whole lot of them. There's several different reasons why the practicality of this might be somewhat in question. First of all, the cost of these are somewhat high. I think one of the cheaper hardware keyloggers I found was like $80. That's kind of expensive for the average person to want to, leave behind. Also, you generally need physical access to a system to be able to install it. That's a bit problematic from an attacker's perspective. But I do have this idea for socially engineering people that might get you to be able to install a hardware keylogger without having to be physically there yourself. Now, as my old joke goes, I'm not a social engineer. I use my personality as birth control. But let's say that you are a social engineer. How many people here have experience with hardware anti-piracy dongles? Well, here's what you do. You find a piece of demoware that you think someone might like. You say, hey, I want to give you this demoware, and I got a dongle you can use to automatically make it not expire. Matter of fact, it doesn't even take up a USB port. It just plugs in line with your current keyboard, and everything will work just fine. You give them that. You give them the demoware. Then when the demoware expires and they write you back, you say, oh, good, I must have sent you a bad dongle. Send me back the dongle, and I'll send you a new one. Now, tell me, how many people you think might fall for that one? So that's a possibility. Also, the USB spec is a lot tougher to implement, and I've been finding this out recently myself, than PS2. So I've had all sorts of reliability issues with some of my USB keyloggers. A lot of them have weird issues, which I'll be talking about here shortly. And on a related note, when the people who are selling these hardware keyloggers, one of the things that gets me about the way they advertise them, they say, monitor your kids or workers. If you don't do that, there's all sorts of better software solutions. They also say, use it as a backup system. All right, this costs, I think this one might be, actually this one might be like $200 or something. Some of these are really pricey. What kind of hard drive can I get for $200? Oh, hell, even the cheap ones, I mean, let's say $80. What kind of hard drive can I get? I can get like a, 1.5 terabyte now? 2 terabyte now? Not to mention, I don't know how you all write documents, but I'm typing up here, I'm typing down here, I'm typing up here, I'm typing down here. Recovering my documents for one of these things would like totally suck. Basically, ultimately, it's for people spying on their wives and husbands, let's face it. First of all, detection and mitigation for these, physical security. If you actually inspect your machine and find it, that's probably a good call. People seem to look around this machine. Now, granted, there are ways of hiding these keyloggers inside of a keyboard, but that takes a little bit more effort because you have to have time with the machine or have a matching keyboard you can swap out. You can lock down the hardware, which I'll be showing here shortly. Unfortunately, locking down the hardware, some of these devices are more passive than others. Okay, I have one of my devices. When you plug it in, it shows up as a USB hub if you go underneath a device manager. But it's pretty innocuous vendor ID and product ID. It says it belongs to Texas Instruments. Probably nothing that's going to, signal you to be paranoid. Most of these, however, are completely passive. You plug them in, you don't see anything. It doesn't enumerate as anything on the USB bus. So there's only so much you can do to actually physically lock down your system. Physical inspection is pretty much your best call. And of course, physical security is to make sure people can't actually get into your facility to install them in the first place. Now, a few things you might want to look for that could lead to the detection is, once again, odd USB vendor and product IDs. But like I said, the only one I've had that showed up as anything showed up as a Texas Instruments hub. Like I said, pretty innocuous. Also, strange enough, inline devices don't always work properly when a hardware keylogger is in the mix. essentially it doesn't pass the signals along right or something, and so you'll have weird effects like the keyboard may not work at all. That's an instant clue. The hub that's built into the keyboard, if the keyboard has a hub built into it, that may not work. Just all sorts of weird issues. Devices dropping down from 2.0 speeds to 1.1 speeds, those sorts of issues. All right, if you want more info on hardware keyloggers, I actually gave a presentation at Freaknik a couple years ago where you can find a ton of details where I actually go through and talk about hardware keyloggers in greater depth than I will in this presentation. Also, I have a buttload of reviews. Please excuse the incredibly Google-friendly or Google indexing-friendly URLs, but kind of human-sucky URLs I have up on that screen right now. The slides for this will probably be up on my website before long and Shmoocon's website. Okay, also, I believe all those are in that paper I mentioned at the beginning of the talk. The next category, and the one I'm going to spend a little more time on, and part of the reason I was rushing through the first part, because I want to have time to show all this stuff off, is the programmable HID USB keyboard dongle devices, or as I call them by their acronym, FUCKed. Essentially what I'm doing is I got a simple microcontroller, and it can act as a keyboard, USB HID device. You plug it in, and anything you can do with a keyboard and mouse, you can essentially script with one of these and have it do your bidding. Many more information on this project can actually be found on my website, where I give you the full source code, schematics, and whatnot for building some of the devices I'm going to be showing today. Now, why would an attacker want to make their own programmable keyboard? Well, there's several different reasons why someone might want to go about doing this. Likely, it can type faster than you. So you plug it in, and you can have it perfectly type what it is the commands you want to send, and do it more surreptitiously because you can walk up behind the machine, plug it in, and have it go, as opposed to having to sit down in front of the keyboard yourself. It also works even when U-Free Auto Run is turned off because it comes as a HID device. And most OSs, by default, I've encountered, automatically install HID devices for you as soon as you plug them in. By the way, HID is a human interface device, in case I didn't mention that earlier. Like I said, it draws a lot less attention. And you can also set to go off in environmental conditions. For instance, the U-Free thumb drive, you plug it in, it goes at that point. You can set this to go off via a timer or lighting conditions or temperature conditions, depending on what extra circuitry you put around it. And also, it can be hidden in other items. You see this mouse that's sitting up on my table here? I'll be talking about that in a second. Just use your imagination. Okay, possible payloads. You can make it add a user to the box or domain. That's a possible payload. Drop out to a command prompt, do some stuff. Run a program and set up a backdoor. Copy files to a thumb drive or upload them to a site that the attacker controls. That's another option. Go to a website. This is going to be kind of like a, let's say you know your, I had a payload once implemented for Facebook. Essentially, after a certain amount of time, you could set it to go to Facebook. If the person was already logged into Facebook and had a cookie stored for it, you could have it go out to Facebook and make a post as them. Now, if they have a bank that doesn't have proper cross-site request forgery protections, or even if they did have proper cross-site request forgery protections, it wouldn't matter because you can actually directly tell the browser, go here. So if they had a cookie stored for it, make it go there and do whatever transaction you want. All sorts of really fun, evil things. So it's sort of like a hardware-based cross-site request forgery, even though that's not really an accurate comparison. But I hope you get the idea. Basically, if you know there's a malware on a certain site that you want automatically installed, have this keyboard install it for you. All right, trigger vectors. Once again, you can make it timer-based. Have it go off 8 hours after it's been plugged in. You can make it listen for lock keys. This is like your scroll lock, your caps lock, num lock. Basically, most of the devices I've been designing are one way, and they don't know what you're typing, so it's hard to trigger them under certain circumstances. However, scroll lock, caps lock, and num lock keys, whenever they're turned on and off, that message gets sent to all keyboards on the system. So that's a way you can kind of get some insight into what the user is doing on the box. Oh, someone on the Hack5 forums gave me the suggestion of using caps lock. Turn on caps lock, and when someone turns it, it's to be annoying. And when someone turns it off, you know someone's at the keyboard, so you know someone's probably logged in. So then is the time you could send your payload. Also, light, motion, and some other environmental conditions. Now here's a few sample ones I've made. I've actually gotten better and better at it. All right, some of these are ones I made in an Altoids can. Some of the other ones are a little bit more refined, and I'll be showing them off in a second. Now, one I have here is this little mouse that I've embedded a Tinsy in. By the way, the Tinsy chips are pretty cheap. The cheapest one's like 18 bucks. I've embedded that in here with a USB hub and some USB storage. And essentially the idea is when it gets plugged in, it's supposed to set scroll lock and wait for it to be changed. Now this could be caps lock or whatever. And whenever that particular key sequence is hit, the message gets sent to all the keyboards. There is no reason why it should be doing that. All right. All right. What you see it just did was I didn't make my sacrifice to the demo gods in proper fashion. Essentially, it waits for scroll lock and then starts trying to copy everything off the desktop to the onboard storage that's inside of that mouse. And right now you see it's moving Chris and his T-shirt into the onboard storage. Sorry. I didn't know you were the demo god. All right, but that's the mouse, which is kind of nifty, but I got some other things to demo, and hopefully they're going to whine less when I plug them in and out. I was so expecting someone out there to scream out, "That's what she said." All right, I'm going to need this in a second. I have a thing for lasers. What can I say? All right, that one's embedded in something else, and I've had other versions of this, like Tenacity's logo is this wolf. So as an impromptu idea, I took a wolf and hollowed it out and embedded a Tinsy in it, made the eyes glow. You could give that to someone as a desktop toy, which you see in the bottom left-hand corner, and get someone to plug it in, have it just do some flashy lights or do something kind of cool, and then have it set off and go its payload later on. So if you want to target a company, you know, send the CEO a desktop toy that's designed like the logo for his company, or an animal he likes, or if you know he's a skier, make yourself a little Tinsy-controlled servo skier that does the slalom jumps or something. But this one is a little unit I set up mostly for demoing what you can do with a Tinsy. Probably in most cases you'd want it embedded in something else so you can hide the fact that you're about to do something malicious. But let me bring this one up and show it to everyone. Alright, since I have a bad memory for things, as anybody who's met me at a conference knows and I can't remember your name, it takes about 3 times before I seem to be able to recall people's names. I have a bad memory, so I've set the first dip switch on this to basically just dump information about what does what on the keyboard. Number 1 is dump this information. And I have it set to go off via a little push button, and I can choose which program to run based on dip switches. All of the schematics of this are on my website along with source code. But I use number 1 just so I remember what's what. For instance, I have on 2 here, I have just basically bring up Notepad and type Adrian was here. So I'm using a button press to trigger it here because I'm trying to give a demo, but generally speaking, I'd want to do it by environmental conditions or timing so I can have it go off when I'm not around. So that's the first real simple example. But let's use something a little more complicated, like set the caps lock trap. I got that on number 3, I believe. 4. I can't read. Oh, 3 is irongeek.com. Well, I'm not connected to the internet right now, so that one won't work. Well, it won't work properly. I'll go ahead and hit it anyway. But drops out to, and brings up a web browser, and eventually times out because I'm not connected to the internet. All right, let's try number 4 now. I can take a little more time now since I think I'm doing well for time. Number 4 is set the caps lock trap. Now I just pressed that and you didn't actually see it do anything. However, hopefully when I hit caps lock, like I said, if I'm doing something like this to annoy someone, they're going to want to turn that caps lock off. I'll know someone's on the keyboard and know I can probably dump my payload. So that's another example. All right, let's go ahead and number 6, I don't have prepared for this. It's basically what I have embedded inside that mouse, which failed to work properly at this particular juncture, where it looks on the system, tries to find a drive by its volume name. Basically, when you plug in a USB drive, you're not going to know automatically what drive it's on. So you can't say, copy stuff to the F drive. However, I got a little script I wrote, and it's on my website, that will look for a certain volume label and go to that volume label and find out its drive letter and then copy stuff to that particular drive letter. So, that can be useful. And I have wanted to make a Facebook post, but I'm not on the internet right now, so I won't be showing that one off. And let's go to 7 and 8. First of all, let's go to 8. And I can barely see this up here. Now, 8 is for motion detection. Because my screen size is not quite working right. So basically, whenever it sees ambient light conditions change, like something like a shadow moved in front of it, it triggers. Now, you can also have it set to trigger like 8 minutes or 8 hours after the device saw motion. So there's all sorts of options. But that's a simple example of a motion detector, which you could set up for it. You can also easily hook up a heat sensor or whatnot. The Tensy has a bunch of analog inputs you can use, so that's quite doable. Let me get rid of some windows. And I'm going to show another demo on this particular unit, and then I'm going to move on to a unit that I think is pretty cool. Well, actually, now that I think about it, I got a few more slides to show before that. All right, finally, let's use the brightness detection, which I believe I have on dip number 7. All right. Let the force be with you. Let's see. All right. I'm going to need this in a second. Currently, I have brightness detection set. So I'm going to hold it next to my screen so it has some light, press that button, and see what it says. So the lights seem to be on, obviously. I'm going to cover the little photo sensor. I'm scared of the dark. And finally, and let's see if I can make this function. Don't save. And finally, let's do one last option. That's either on or off for lights, but you don't have to just do it on and off. You have an analog input, so you can do all sorts of stuff. Or maybe not. So, there's all sorts of options there. And there's all sorts of payload ideas. It's just a matter of using your imagination. And I have some more details out on my website on setting up this particular device. All right. Get back to where I left off. Oh, I should also mention that SET, Dave Kennedy's fun little tool, has some payloads you can automatically generate for the Tensy. You just have to compile and upload. All right. A few real-world examples, because Dave Kennedy gave a talk at B-Sides on using the FUC device for various nefarious purposes with SET. Dave Kennedy and Josh Kelly did another talk at DEF CON 18 in Black Hat, Las Vegas in 2010. And Richard Rushings did a talk. Montana Elkins, he did one that actually used wireless as a trigger vector for knowing when to send the keystrokes. There's the USB rubber ducky from the Hack 5 crew. And of course, my own talk from DEF CON 18 if you want more details on building just that particular device. Detection and mitigation, first of all, user awareness. The user should start to know not to plug in every little cubicle toy someone sends them. Physical security, if someone can't get a chance to plug it in, then that's relatively safe. Lock down the hardware so it can't be installed, which I shall be showing here shortly. And physical inspection and watching for weird anomalies. All right, USB lockdown. I'm going to show how you can lock down USB on both Windows and Linux. First of all, in Windows, there's basically some GPO settings you can make, and you can get really anal retentive about allow this particular device, disallow this particular device, and this has been in Windows since, I believe, Vista. So that goes quite a long ways. You can get in there and say, don't install anything by default. Now, my personal recommendation is you set these two particular settings, and unfortunately, those won't actually work for you because that GPO setting, that long, half-random looking string in the middle, is going to vary depending on machine to machine. But there's one called Deny All Removable Devices, and another one that says basically you can pop up a message saying why it was disabled, so the person knows to come talk to an admin. Like, here's my recommendations. First of all, turn on the two options in the GPO settings that say allow administrators to override device installation restriction policies, and also turn off prevent installation or removal of devices. And while you're doing that, you also want to go ahead and set the custom message options, which you see that little pop-up box down the bottom right-hand corner. You want them to know that they have to come talk to an admin to install anything. Now, granted, this isn't a perfect solution, but it's better than nothing, and it means that two people's security training have to fail instead of just one, because the person who plugs it in, you know, has to fail, and then the person who's the admin who actually can install the device for them has to fail as well. But this is just my personal recommendation for ease of use. You can also set it up to where you can blacklist or whitelist certain devices, but keep in mind, the best thing you can usually key on a lot of these devices is its vendor ID and product ID, and you can spoof all that when you set up a Tinsy device. For instance, a lot of mine, I have set to, I think my vendor and product ID are something like 1313 and 666, and you plug it in, it says Cthulhu keyboard and mouse. So, but I could have made it look like it was something from Apple. I actually have a little business card in there, a USB business card. You plug it in, it brings up a web browser and takes you to the vendor's website. And it reports itself as an Apple keyboard, but it ain't an Apple keyboard. All right, Linux lockdown gets a little bit more complicated. You got to know what's out there on your USB bus. There's all sorts of useful commands for doing that. I was having all sorts of problems before Louisville InfoSec figuring this out, and Michael Miller pointed me to some options to use. Basically, inside of sysfs, there's a flag you can set to say whether or not installation of certain USB devices is allowed. So when I was first doing my testing in Linux, I was using Backtrack as my test subject. Unfortunately, it mounts something a little bit weird in sysfs. For instance, let's say I wanted to enable or disable that Western Digital Technologies hard drive. I just use LSUSB, find out what bus and device ID it is, take that information, and then use udev admin info to probe it for strings I can use in what's in a udev script, which at the time the device is plugged in will decide what to do with the device. Unfortunately, Ubuntu doesn't actually have that particular sysfs mapping, so I had to do some more modifications. So it's a little bit harder in Ubuntu. Essentially, the way you authorize or deauthorize the device, if you have its sysfs location, you can, if you want to disable everything, you echo 0 into that particular bus, and into both authorized default and authorized. That makes it disabled. Now, if you want to know which device is which, it gets a little trickier here. The problem is LSUSB gives you bus ID and device ID. However, because of how Ubuntu mounts things inside of sysfs, what you need is the bus ID and the port number. That's a little bit more of a pain. So basically, you have to translate. Notice how on the top one, second from the top, LSUSB gives me bus 1, device 2, but that exact same device, and trust me on this, is on bus 1, port 1, if I look in sysfs, because the port and device IDs, the numbers aren't really correlated. But I can luckily find that information by issuing another command, lsusb-t, look at the tree view, and then look for device 2 on bus 1, and I notice right there, it's on port 1. So I can then use that for probing for more information. The next thing I want to probe with is, and I don't know if you can read that up there, but all this is information that's in my slides, and if you go read that 40-page document I posted, all these details on lockdown are in there. Basically, you can probe that device, and you get all these different device strings that you can use in your script to trigger on. You can do it on, if you have a serial number, that's probably the best thing to do it on, but not all USB devices have serial numbers. Once again, it's kind of easy to spoof this. Now here's a simple, relatively, script I wrote for UDEV. Essentially, this top one, what it's doing is whenever it sees something added, it automatically deauthorizes everything by default that's not already installed. Then, after that, based on what the device is, it decides what to do with it. For instance, if it sees that it's something that matches this particular vendor ID and product ID, it automatically allows it. I don't know which one this particular device was. It might have been my webcam. If it sees this particular serial number, it authorizes it. And you can base it on all these different strings I was showing you before. That's why using that UDEV command is so useful. You can just copy and paste what your matching argument is. You can also choose to deauthorize stuff if you wish as well. You see, I also base it on a description string, the product description string. There's like a ton of different options for UDEV. I think we should find someone who's good at Python to write a script to make this more automated. But I'm not sure who that would be. You know, someone I know. I'll figure out someone to ask. Because currently you have to do all this crap by hand. It'd be nice if you just had like a drop-down tree view and you can say, allow this type device, disallow this type device. But there's a lot more rules, information on this in my article, also on the URLs I have at the bottom of this particular slide. All right, finding the needed information to lock all this down. Now, I already covered that in Linux to a degree. In Windows, you can go into Device Manager and find out information about the USB devices that are installed, but it's kind of a pain to navigate. I highly recommend you use USB dview. Gives you all the information you're probably going to want about a USB device. You can export it to a common separated values file and manipulate it any way you want. Now, if you want to remotely collect this information, for instance, in Windows, let's say you know someone's using a certain thumb drive, or you suspect someone of a certain thumb drive is being your Typhoid Mary carrying something like Conflicker around your network. Well, wouldn't it be nice if you can probe your entire network and see where that thumb drive's been plugged in? Doing something like this, you can. Along with a USB dview, what you do is you create a text file very similar to the contents I have in that top bullet point, and you can probe each one of those machines in series. Then you use this particular command line and dump your output into a CSV file, and you can see all the different machines where that particular thumb drive or other USB device had been plugged in. So you can figure out who your Typhoid Mary is carrying some malware around your network. More details are, once again, on my website. Also, this allows you to look for those suspicious vendor IDs. Like if you know someone has been using Tinsy devices and they've been a wise ass like me using 1313 and 666 as vendor and project ID, this can help you. Also, scanning for machines that have 2 keyboards hooked in might give you kind of a clue. You should check it out, though that's no absolute indicator because someone could have, there's all sorts of reasons why someone might have 2 keyboard HID devices plugged in. Also, if you see like a Dell machine that has an Apple keyboard plugged in, it might be something worth looking into as well. Now, future plans, and this is going to be my last demo, especially since I'm running close to being out of time. Feel free to talk to me anytime at the conference about this, and I'll see what I can do for helping you out and with more information. Future plans for doing all this stuff is I want to create scripts to help lock down these USB devices in Linux, because it's not very convenient right now. Like I said, I just got to find someone that's really good at Python, maybe someone I know in a conference I'm helping organize, you know, someone like that that can help me out. Okay. I also want to make a keylogger fucked hybrid. Basically, it sits in the middle, sees what keystrokes you're sending, and can use that to figure out what payloads it wants to use and information. And originally that was a future plan, but like a week ago, I got my programmer in, and I've actually done some work on this. The idea is essentially you make a keylogger, and it can look for all sorts of keystrokes, and it can dump it to an SD card or whatnot if you really wanted to. But you can also have it look for certain things like Control-Delete, something typed in, tab, something else typed in, enter. Now, depending on how the login system is set up on that particular box, what might that give me? Correct. I found Shuri Electronics, and they had this little HID to serial adapter. Now, there's all sorts of practical limitations with this particular device, and luckily I've convinced them to give me the source code, thanks Shuri Electronics, so hopefully I can fix some of the issues, because their device doesn't work with all keyboards, and it doesn't report the Windows key and a few other oddities. But I think I have just enough to show you a proof of concept demo here. Let's see what happens. Always remember, failure is always an option. All right. All right. I am now logged out of my box. I have a keyboard over here. And everybody tells me I should always use a very good password. Look, Ma, no hands. Unless I have a complete colossal failure, which is, like I said, always an option. Chris, you are not the demo god. A very good password was my password. I could essentially reuse something the person typed later on for other items, as long as I can figure out what keystrokes to grab out of. And eventually I want to make a version that actually dumps everything to an SD card as well. So that almost finishes my presentation, and I'm going to just bring up my wrong slide deck, Adrian. Let me bring this up. By the way, source code for all this, I'll give it to you now. It's ugly spaghetti code crap. But eventually, when I get something that's actually, you know, pretty, I do plan on posting this, assuming I don't have complete failure. And if anybody knows any better devices I could use for this, let me know. Because there might be something else out there already that will do a better job than this device from Shuri Electronics. It's a little PIC chip on this Shuri device, and I have it feeding into the Tinsy, which is an AVR device. There might be something else that's already an all-in-one unit that I could program that would do a better job. I don't know. All right, a few announcements, events. DerbyCon 2011. Woo! Louisville InfoSec as well, and a buttload of other cons I want to give shout-outs to because I love going to security conferences. SkyDogCon. Woo! DojoCon, HackerCon, Freaknik, Not a Con, and of course AutoZone, which is coming up in March 18th and 19th. Finally, any questions? But since I'm running very close to the time for the next speaker to get up here, I probably should start stepping off. But if anybody has any questions, just get with me anytime during the conference.